the bench this morning. On the bench this morning, Pioneer SX-737. Beautiful. I love it. Weighs quite a bit. Model 74 to 76, probably about 50 years old. In the shop today because he's saying there's a bit of noise on the right channel, which we'll test before we open this up. But all in all, I just wanted to see the quality. Look how beautiful this is. Maybe it is 50 years old. The veneer looks really nice. A few cuffs on the top. It's a light quality stereo for sure. Not the most expensive Pioneer, but definitely up there. And it's really beautiful. I love the knobs. The clicking sounds is really nice. All these knobs and these switches is all you need in a stereo. 35 watts, that's quite powerful. Not too much power, but not too little power either. A customer says that he worked on a power supply a couple of years ago. He's not sure what they've done with it. He's hearing a bit of noise on the right channel. So I'm going to take a look at it. We'll check the bias as well, see if we can do anything with that. All in all, it's going to be a nice little project. The power, the switch on and off is kind of hard to on and off, so we'll take a look at that. I'm going to power this up. Relay clicked in, which is good. It is kind of drawing a little bit of power. The lamp seems to be working okay. I don't know what, it seems to be working okay. Anyways, we're going to open this up and see what we can find. And we're going to do it right now. Okay. It's nice design, eh? Look at the size of this transformer. Must be punching a lot. This is the power supply where I'm getting all my voltage. Yeah, they have changed 1, 2, 3, 4, 5, 6 capacitors on here. Okay. We'll check some voltage here, see if that's working okay. This is the power amp board. I see an issue here. This must be a resistor, 150 ohm resistor maybe? It seems like it's been heated up a little bit. I don't know. We'll do some voltage testing. You can see this. Turn this on. This is on. I'm going to do the DC voltage here. My minus to my output transistors. Okay, 31 plus minus 31, that's good. Okay, I'm not sure why resistors are for setting the bias. Maybe the bias is off on the right channel. What do you guys think? Let's see. I got 28 millivolts there. And I got 17 millivolts on the left channel. What I'm going to do, since they've changed capacitors on here, just wondering if I'm getting the right voltage. So we're going to get a schematic for this, and I'm going to explore, first of all, the power supply board. And then we'll see, I'm getting 31 voltage. My B plus and my B minus is 31 volt. I just want to make sure that those are the right voltage that I'm supposed to get. I'm not sure. I'm going to check this resistor as well. I'm going to shut this off. And we'll start from there. What I'm going to do is take the bottom plate out before I poke any of my stuff in here. I want to make sure there's no voltage into this. Okay, so I'm going to take this bottom plate out. Okay, it's really nice and clean. These are my two big caps that I'm worried that they are still charged. So let's test them. Put this to DC voltage. Even though this has been shut off for about 5 minutes, there's still 31 volts. So I need to discharge that. And I'll show you how I do this. This is an important thing that you need to remember is when you shut the power off, even though there's no power here, there's still voltage here, 31 volts on these big power supply capacitors, so we need to discharge them. So this is just a rod with a 150 ohm resistor soldered to this, and the other end of the resistor is this clip here. So this clip goes onto the chassis. There's my voltage, 31 volt. I'm going to discharge that by just touching it. See this? The voltage is going down. I'm going to stop it at 0. There. Now I'm going to do the other capacitor as well. There's the other one. You see there's 31 volts. All I need to do is touch it. 150 ohm resistor is taking all the heat. So all it does is the rod touches the positive part of the capacitor, and the resistor attached to this dissipate the energy that's stored in the cap. You can actually feel the resistor is nice and warm. So now I have 0 voltage on these caps. I'm safe to start poking in this receiver. Never trust the power on and off button. These capacitors hold a lot of energy, and I can't stress this enough. If you poke your stuff in here, you can still get a zap. You can damage your electrical stuff, or you can even get a shock. There was 60 volts here. Okay, so I'll put this away. Flip this around. Okay. Now that I have no more power to this, I'm going to check that resistor. So this is a 150 ohm resistor. I'll check this one. This is 430 kilo ohm resistor. This resistor is open, and I believe this resistor has something to do with your bias. The right channel was still working. That might have caused him some noise. I'm not sure. I'm not sure why this would be open, but I bet you the bias is not set properly. This is supposed to be a 150 ohm resistor. You guys can see that it's 340 kilo ohm resistor. Here's a good resistor, which is the same as this one, so we just compare, right? This should be a 150 ohm resistor, and you have 150 ohm here, but not here. So that's an issue. This issue here would control your bias, I believe. I'll have to look at the schematic, but I'm sure the bias is not set properly on this. We'll check the left channel. And 150. The emitter resistor here are 4.70, 4.70, 4.7, 4.7. Yeah, I don't know what happened to this resistor. But anyways, obviously looks like the power amp board has never been touched. I still have the old capacitors on there. Everything is working okay, except that I'm pretty sure my bias is not set. And I'm going to test that right now. This. You guys can see this. On this page, the SX-737, I'll be able to check the DC neutral voltage and the idle current. Right now, I'm just curious about the idle current. Connect the DC voltage between pin 2 and pin 1. Okay, pin 1 and 2 is on for the left channel, and pin 18 and 19, which is on the other end. And I should be getting 20 millivolts. Power this on, and just by curiosity, without touching this, I want to see if my bias is set. And go 2 millivolts. There it is. Now he's saying pin 1 and 2 for the left channel, 14 millivolts, 15 millivolts, but it's going to go up because I just turned it on. Not set now. Curious about the right channel. It's at 27 millivolts. So I believe this 150 ohm resistor that is open has something to do with my bias. And we're we're going to check that. Okay. Not sure if that's the right voltage, but what I'm interested in is I'm going to be checking the voltage on the power supply board first. And this is what I want to do. So I'm going to bring you closer to this. I've downloaded this on the computer, hoping that you guys can see. So 120 volt comes in from the outlet on the wall, goes through a transformer. Transformer brings it from the primary winding to the secondary winding. The secondary winding on this schematic is divided in 3 phases. The phase number 1, that I'm going to say number 1, these are the lamp. They don't have to go through a rectifier because lamps needs AC voltage. So the lamps are hooked up directly to the transformer. Okay. The phase number 2 and 3, this voltage needs to be going through a rectifier in order to get DC voltage on this side. Okay. So AC volt comes in, goes through a rectifier, comes out DC voltage. I'm going to set myself a good ground. Here's a good ground. There we go. And I'll put I think we'll be able to see that, eh? Okay, got some AC voltage here. Pin number 1. Let's go to pin number 1. Pin number 1 is AC voltage. It's given me 7.32, and those are for my lamps. This is the one here. Okay, so that's okay. This is directly from the transformer. Now phase 2 and 3, pin number 3, I should be getting 34. Pin number 4, 34.8. Pin number 8, 24. Pin number 11, 24. And pin number 6, 32. 9 and 10. 9 and 10 is through a rectifier, so that'll be DC volts. So this is what I'm getting coming out of my transformer. So pin number 3 is 34. Pin number 4, 34. And this is AC voltage. Pin number 8, 24. Pin number 6, 32. Pin number 11 is 24. Okay, so pin number 9 and 10, I'd have to switch that over because it's gone through the rectifier. So pin number 9, I've got 31 volts. Pin number 10, minus 31 volt. Okay, so this is where I should be getting 37 volts. But let's check my other voltage. 14 and 15. 14 in DC volts, I should have 35 volts. And I've got 36. 36, 15. 15 is 31.5. 15 and 16 should be 31 volts, 0.5, so that's pretty close. 17, 24 volts, and I've got 23.6. Pin 19 and 20, I should have 13.5. 13, I'm getting 13.4, that's close enough. On on the 12 pin, 12 and 13, I should get my minus 13 volts, minus 12.95, 12.95, so that's good. And pin number 7, I should get 38 volts, and I've got 33 volts. Something is robbing me of 5 volts. And I believe that could be due to my bias that's not really set properly because of that resistor. Anyways, I just wanted to show you the before and after. Okay. Some of these capacitors are probably old and leakage. They're not probably old, they are old, and they're probably leaking. So I'll check all these capacitors. There's not a lot of them. There's only 1, 2, 3, 4, 5, 6 capacitors, and I'm changing this resistor, and then we'll test it again, see how that goes. Alright, I'm putting you on the stand. Put this on ohm, and let's check this 150 ohm resistor. It's open. This resistor is open, and this is 150 ohm. Okay, so this resistor is going to go in. Brand new resistor. I'm going to change some of these capacitors. I do. Alright, and there it is. It's supposed to be 47, it's at 59. The value is off, so you know what, I am going to change all of these. This is a 220 at 16 volts. 220 at 16 volts. We'll change these with Nichicon. Good quality. The long leg is the positive, short leg is the negative, and it's also shown here that this is the negative. Okay, so just make sure the polarization goes in correctly. Okay, I've replaced this resistor, change all these caps, and this is going to help me with my bias. Okay, I'm ready to set the bias on this Pioneer SX-737. So it's telling me here that to connect pin number 1, pin number pin number 1 and pin number 2 for the left channel, and pin 18 and 19 for the right channel. And the pot number 3 and 4, which is the two center ones, which is those two right there. They're center ones. So obviously this one would be for the left and this one here would be for the right. And these are the ones that I need to adjust to bring me to 20 millivolts. Okay. So I'll go to pin number 1. We'll do the left channel first, I guess. Why? Well, I don't know, because I said so. Okay, left channel is high, so we'll bring that down. You guys seeing this? So they want pot number 3. Gonna try to bring this down. Pot number 3. Okay, clockwise gives me 44 millivolts. Counterclockwise gives me 46 millivolts. That can't be right. I bet you this is an error in the printout. Okay, let me read this again. Adjust VR3 and VR4 to 20 millivolts. So this is VR3 and VR4, which is the center ones. And I just did that and nothing happened. Let's try the right channel. The right channel is pin 18 and 19. This has got 60 millivolts. Clockwise is 58. Counterclockwise is 64. That's not it. So we'll leave it on the right channel, pin 18 and 19. But I am betting money that this is pod number 1. This is the one, not this one. Let's try it. And there you go. It's responding well. So I'm going to bring this down to 20 millivolts. So it's just an error in the printout. $20 millivolts. Should I bring it a little higher for you guys? If you guys want. Okay. 20.5. You guys okay with that? Okay, so I've used the VR number 1 instead of the VR number 3. Okay, it's just an error in the printout. It's no big deal. As long as you catch it and you guys know it. Now I'm going to do pot number 1 on this one. I don't know if you guys can see that. Yeah, pot number 1 is 45 millivolts, so I need to bring this down. Okay, let's do it. Down to 20. 20.5. I'm going to leave it there. That's perfect. Now, we are going to check our DC voltage. And according to this, they want me to use pin number 3. So, pin number 3 is right here. And to ground chassis. So I'll just use a ground. I'll use one of the negative on the speaker terminal. How's that? There it is. You guys can see that. And look how much DC voltage I have. This needs to come down. I mean, it's at 0.05, but I was told by somebody that anything 50 millivolt, he wouldn't be comfortable with it, and I'm going to see if I can adjust that. So, let's see. I'm going to use this pod number 4. Look at that, responding well. I'm bringing this down to, well, at 0, as much as I can to 0 anyway, or as close as I can to 0. Look at this, and this is measuring in millivolts, eh? This is hardly. Look at this, 0.1 to 2, and that is measuring in millivolts. In volt, it's 0.003. This is perfect. Let's try the right channel. We need to go to pin 17. Pin 17 is at 56 as well, so we'll use pot number 3 on this one. And let's go down to the closest I can get to 0, the better, because this is for DC offset, right? Yeah, I'm going back up, so I'm going to have to turn this around. If I could bring it under 10, I'll be really happy. Jesus, this is off. So let's go to DC. You know what? I'm okay with that. It's just as close as I can get it. Look at this. This is pretty cool. Under 10. I was really comfortable with that one. Okay. So this is how you set your DC offset. So I'm pretty comfortable with that. So now the biased and the offset, the DC offset is set properly. Now we're going to go to the next step. Okay. Now you guys remember that I'd had some discrepancy in the voltage. Let's check this out. Okay. Pin 9, 36, 36.5, I should have 37. And pin 10, 36.5, and I should have 37. I'm pretty happy with that. Let's go down to pin 7. I should have 38 volts, and that's exactly what I'm getting. 38 volts. Pin 15, 15, 15 and 16 are 31.5 volts, and I'm at 31.9, which is perfect. Pin 17 should have 24 volts, 23.99. Pin 19 and 20, 19, 13, 13 volts, and that's what I'm supposed to get. And 12 and 13 should be my negative 13. Negative 13, 13. And number 7, there's my number 7. I had 31 volts before. Let's go C7. 38, and I should have 38. I'm really good. I'm really happy with this, and these are, I'm measuring the output transistors at 36 volts, 36 volts, 36, 36. Isn't that wonderful? And so my voltage is correct on all of this. No issues at all. There, we're ready to test this sound-wise. I've got my 1000 hertz through my auxiliary. Through my auxiliary goes through my scope under an 8 ohm load. Okay? And I did something differently this time. I've hooked up my multimeter to the speaker terminal. I can only do one channel at a time, of course, because I've only got, you know, the one of these. But we will certainly compare from the scope to the multimeter, see if we get the same voltage. And this will be measured at AC volt. Okay, so let's crank this up. I'll put it half, and there it is, 4.4 roots mean square. That's what that means. So it's giving me 4.4 voltage. Okay, let's see what on my multimeter, which is hooked up on the left speaker. It's a little higher, but it's understandable. It's just hooked directly to the speaker terminal. I could easily say that this would be a little more precise. Okay, so 4.6 compared to 4.4. Let's crank this up to full volume, or until I get a distortion. Okay, so there we go. I can't go any higher. The volume is right up there. Under an 8 ohm load, I have 0 distortion. That's amazing. And I'm reading 16 volts per division. Let's compare the multimeter. 16.9. This is 17 volts per division. RMS. So 17 times 17, and you divide that by 8 ohm load, will give you your watts per channel. Look at this. Beautiful. I'm going to kick this back because I had this full tilt. And when you're doing this test, you need to have everything neutral, okay? So like the bass was at neutral, the treble was at neutral, the loudness is off, You want nothing running on this. Okay, and it's under an 8 ohm load. So you know what, guys? This is pretty cool, and I just wanted to show you guys that you don't really need a scope. All you need is one of them. So this thing is perfect. Now I'm going to play some music. Back together. Anyway, guys, the stereo is completely serviced. Showed you a couple of issues that I had with this. One of them was this resistor was open. I changed all the capacitors and I've changed one resistor that was open. I set the bias to 20 millivolts as per Pioneer asking for. That looks fantastic. I've cleaned all the pots and the switches. It looks and sounds fantastic. It's giving me 36 watts per channel. No distortion, zero whatsoever. I can bring this all the way up and no distortion. It sounds really nice. Anyways, I think the customer's going to be happy with this. If you like my channel, please subscribe to it. That would really help me out. And we'll see you in the next video.